Calculus, determine concavity and points of inflection. Here we have our introductory explanation. It says determine concavity in POIs. POI standing for points of inflection. And here we have a process, a three-step process. And we're going to observe this process in terms of the four problems shown. What you're going to do first is find PPOIs, which are potential points of inflection, and that will be where y double prime is equal to 0 or where y double prime is undefined. And then if we actually see where the value signs change from negative to positive or positive to negative, that will determine a point of inflection. And then concavity, if y double prime is greater than 0, we have that interval of the function concave up. If y double prime is less than 0, that interval of the function is concave down. And graphically, what concave up looks like is this, and what concave down is, it looks like this. So let's go ahead and work these four problems. And as always, I invite the viewer to pause the video, work as far as you can, and then play ahead to see if you got it right. Okay, number one, the graph of y equals 3x to the fourth power minus 16x cubed plus 24x squared plus 40 is concave down for what intervals? Well, the first thing we're going to do is find concavity. That's going to be found by taking the second derivative and setting that second derivative equal to 0. But before we get to the second derivative, what do we need to have first? The first derivative. So we have y equals 3x to the fourth power. Y prime is going to be using the power rule, 12 x to the third power. Hope you can see that. Minus, we have 3 times 16, so we have 48 x squared. And then we have plus 2 times 24, 48x. And now we're going to go to y, find y double prime. And that's going to be equal to 3 times 12, or 36. And 2 times 48, we have 96. Plus 48. And then we can find a common factor here, which would be 12. So y double prime is equal to 12 times 3x squared, and 96 divided by 3 is going to be, divided by 12 is going to be 8, I believe. Is that right? Yes. So minus 8x. And then 48 divided by 12 is going to be 4. And so we have this quadratic trinomial. If we set, we will set this equal to 0. So 0 is going to be equal to 3x squared minus 8x plus 4. And then using our x method of factoring, we have AC up here and B down here. So AC is going to be 12, and B is going to be negative 8. So we ask ourselves the question, what two numbers do you add together to get negative 8, yet multiply together equal 12? We're going to have a negative times a negative. So that's going to be negative 6 and negative 2. and we divide these respectively by a, which is 3. And on the left side, we get -2. So what we're going to have is x minus 2 times x minus 2/3. So we use the bottoms up method for this. We get 0 is equal to x minus 2. And then we have 3x, that's 3x minus 2. And then if we set each one of these factors equal to 0, we have x equals 2 and x equals 2/3. And then my recommendation for finding concavity is to draw a number line and put our critical numbers on the number line. And we have 2/3 here, and then 2 here. We're going to put y double prime above the line and y down below. So we're just going to have during these intervals concave up and concave down. So what we do is we just look for the sign, and we can use any version of the function here we want. So my recommendation is to use the numbers that are just simplest, for which the arithmetic is simplest. So if we plug in 0, we're going to get a -2 times -2. So we're going to have positive. It's going to be concave up from greater than -30 or less than 2/3. And then if we use a number between 2/3 and 2, like 1, we're going to get a negative times a positive or negative. So we're going to be concave down in this interval. And then a number greater than 2, we're going to have a concave up in this interval. So we're going to say function, I'll just say function is concave down on the interval from 2/3 to 2, because y double prime is less than 0. And that will be our answer. And our justification. Always important to put our justification out there. Okay, number 2. Again, I invite you to pause the video and then look at it afterwards and see if you got it right. Okay, same thing as before. We need to find the second derivative. So the first derivative is going to be f5 of x. The derivative of sine x is going to be cosine x. And then we're going to take our second derivative, f double 5 of x, is going to be equal to the derivative of cosine, is going to be negative sine x. And so we're going to set this equal to 0 and see where the sign is. So we say 0 is equal to negative sine x. And if we go from 0 to 3 pi, we're going to have x is going to be, if you can imagine a circle at pi over 2, well, at where's the sign? 0. We're going to have certainly 0. and also at x equals pi, we'll have x equals 2 pi, and x is equal to 3 pi. So these would be our values of 0. So really what that looks like is this. We're going to have up above, we're going to put f double prime of x and f below. And our points of inflection, our endpoints are going to be 0 and 3 pi. And we're going to be interested really between pi and 2 pi. Because even though 0 and 3 pi are on the very ends, we're not going to have points of inflection because we don't have domain outside of either of those. So, and we don't have any. So we're interested in these three intervals here. So we just try different numbers. We can try, for instance, pi over 2. And if we try pi over 2, what is the sign of pi over 2? That's going to be 1, but we have a negative out front. We're going to be negative in this interval. So we're going to be concave down in this interval. Between pi and 2 pi, we have 3 pi over 2. And that's the sign of that is negative 1. Well, negative 1 is positive. So we are concave up on this interval between pi and 2 pi. And then the last one we have is when we go around the circle again, we're going to be negative in this interval. So what we're going to have is f of x, answering the question, is concave up on the interval from pi to 2 pi because f double prime of x is less than 0. Now for points of inflection, we have points of inflection at x equals pi and x equals 2 pi because we changed concavity. So points of inflection, we have x equals pi, and that's going to be, if we plug in for sine x plus 2, f of pi is equal to sine pi, which is 0, plus 2 is equal to 2. And so our point of inflection is going to be the coordinate pair pi, comma 2. Okay, and then also for x is equal to 2 pi, we're going to have f of 2 pi is equal to sine 2 pi plus 2. That's going to be equal to 2 also. So this point of inflection is going to be 0.2 pi, comma 2. So here we have our concave up interval, and here we have our points of inflection. Now I invite the viewer to pause the video, work out number 3, and then play ahead to see if you got it right. Okay, for this one right here, and I previously worked this out ahead, so I'm just going to scroll to a completely worked out problem. And it really shows, first of all, taking this function and converting this from a radical form to a rational form. and then taking the first derivative, second derivative, setting this second derivative equal to 0. Now, in this case, we do not have a value here. You see, this is undefined. This is the case in the vertical tangent line, is what it amounts to. But it just shows the process. We find where the function is undefined. So you take this 2x minus 1, set it equals 0, so x equals 1/2. That's going to be our possible point of inflection. And we see that using the test, there are concavity changes. And so we have concave down and concave up over these intervals. And then we have our point of inflection putting in 1/2 at 1/2 comma 0. Okay. For an equation line tangent to y equals x cubed plus 3x squared plus 2 at its point of inflection is, and again, I invite you to pause the video and work it out ahead and play ahead to see if you got it right. Okay, well, what we need to have a tangent line is two things. We have a point and a slope. And starting out with this, we really have neither, because we have to find out where a point of inflection. And in this case, they say we have one point of inflection. So we can assume if we have a possible point of inflection, that's going to end up being our point of inflection. So the first thing we're going to do is take y prime, and that's going to be equal to x squared plus 6x, and y double prime is going to be equal to 6x plus 6. Now if we set the second derivative equal to 0, 0 equals 6x plus 6, which is going to be 0 is equal to 6 times quantity x plus 1. So 0 is equal to x plus 1. So we have a point of inflection where x is equal to -1. So can you see that? Because we solve for x, we get x equals -1. So our point is going to be -1, comma, something else. What we have to do is plug -1 into this first function. So we put y of -1 is equal to -1 cubed plus 3 times -1 squared plus 2. And so y of -1 is going to be -1 plus 3 plus 2, which is going to be 4. So we have our point is -1 comma 4. Now our slope. What we have to do for our slope is we have to go and use this equation here. So I'm going to bring this down here and put in y prime of -1. It's going to give us our slope. So that's going to be 3 times -1 squared plus 6 times -1. So y prime of -1 is going to be equal to 3 minus 6, which equals -3. So that's going to be our slope. So m sub t is equal to -3. So our line, we're going to be able to use our point slope form. We're going to have y minus y1 equals m plus 20x minus x1. So we have y minus 4 equals -3 times x minus -1, which is +1. So this will be our equation of our tangent line at this inflection point. And the inflection point will occur where x equals -1. So that's it. I hope this can help you. Good luck, and thanks for being.